Hi, my name is SYAZWAN FIKRI bin MOHAMMAD. Today, I'm going to present my FIKRI project titled Thermal Degradation Behaviour of Carbon Fiber Waste as a Filler in Polymer Composites. So, I'm going to start with the introduction part. What is carbon fiber prepreg? It is a fabric reinforcement that has been pre-impregnated with a resin system. However, there is a problem where when the carbon fiber prepreg expired, it will cause the material to become harder than its original condition. Does the thermal behavior of it still as same its best conditions? So, in this project, we are going to look on that part. In this project, there are two main objectives. First one is to form polymer hybrid composite by combining recycled carbon fiber, glass fiber and polypropylene. Second is to conduct thermal tests to study the composite thermal behavior. As for objective, first is to observe mass loss due heating process. Second is to conduct TGA on the composite. Third is to conduct mechanical test, which is Rockwell hardness test. Before we can start to the main discussion, there are several research that have been done regarding to this hybrid polymer composite. First was from Razana and her colleague on TGA result of PP, glass fiber and multi-wall carbon nanotubes polymer hybrid composite. In her finding, it was found that pure PP has the highest degradation rate compared to all specimens. Second, introductions of glass fiber in the hybrid composite show notable shift compared to pure polypropylene and multi-wall CNT and PP hybrid composite. As two elements were added together, significant improvement of thermal stability have been recorded from H1 to H2. This can be referred in table 2.2. Third, the highest peak temperature for this experiment was H2 at 466 degree, with the weight loss rate of 33.7% per minute. The result can be referred in table 2.2 and figure 2.2. The last one is that the presence of flux might reduce thermal stability as heat dispersion in microstructure was important to ensure degradation at normal condition. Other that, from Rezai and his colleague on TGA result of polypropylene and short carbon fiber polymer composite, in his finding, it was found that first, as the carbon length in the hybrid composite increase, the composite will thermally less affected. This can be referred in figure 2.2 and table 2.1. Second, on additional observation, degradation temperature and weight percentage loss of the composite sorted by different length shows from 10% to 90% of the polymer. Composite shifted the range from originally 362 degrees Celsius to 444.1 degrees Celsius to 400 to 463 degree for 0.5 millimeter length of short carbon fiber. This is as follows when the increasing of the length from 1 millimeter to 2 millimeter to 5 millimeter to 10 millimeter of short carbon fiber. Next, finding on hardness test based on Casley and Altec Carbon fiber content will determine by the fiber loading. Thus, it is affecting in microstructure, which will influence the hybrid polymer composites. This suggests when adding carbon fiber, it will enhance the hardness properties. The result can be seen as shown in the slide. Besides, there are other studies on carbon fiber and all findings show similar results to polypropylene matrix-based polymer composites. Moving on to methodology, the project had 7 steps before the result obtained. First, carbon fiber prepreg 3K 2x2 twill wave carbon with 6-month wave and glass fiber prepreg 7781E class 6-month waves from Fiberglass Development Corporation from USA were cut into small pieces before entered to granulator. The result of it can be shown in the picture. Once all items were ready, it will follow the steps as shown here, which were compounding under 200 melting temperature with 50 rpm. The extrusion result will then be pelletized. After that, it will undergo injection molding under ASTM D638. Then, it will finally tested on these 3 tests, the TGA, heating test, and hardness test. On heating test, material were heated at 1 hour. Initial mass and final mass were recorded for every composition ratio. These were the Gantt chart for the project. As a result, from the testing, figure 4.3 shows 4 graphs. First, 100% of PP, second, 90% of PP, third, 100% of recycled glass fiber, fourth, 100% of recycled carbon fiber. The result suggested that there were degradation curve had shifted from its original position. This means the increase of recycled carbon fiber had affected the thermal degradation behavior. For second test, which was heating by using oven at 1 hour, 3 different temperatures, which were 26 degree at room temperature, 150 degree, and 175 degree. Level 4.2 shows the initial mass for every composition ratio. As the heating taking place, the result in every composition ratio shows rapid degradations as the temperature increase, from room temperature to 150 and finally to 175. Comparing the composition of carbon fiber and glass fiber, the degradations at same temperature increase when both material increase in content. This might be because of inconsistency of thermal loading in structure. Hence, rapid degradation happened at polypropylene. However, TGA result had suggest after prolonged testing, heating process the curve will be shifted from pure PP to the modified one. On hardness test, however, it could indicate the real results. There are 1 specimen that has increased the value, which is specimen 27. It is under 80 weight percentage of polypropylene. However, the trend of degradation affected as the temperature increase. This indicates that thermal can affect the mechanical properties. On the other hand, study in microstructure to get the best carbon fiber loading might come out with better result. To sum up, the thermal degradation shows based on TGA result indicate as expected result. Apart from that, it can also be concluded that as the temperature increase, the mechanical properties shrink. rate of thermodegradation may increase as the composition increase. However, in hardness test, it was not showing the expected result. Only 80% weight percentage of polypropylene had shown higher record compared to other composite ratio. Therefore, it is suggested to do deep structural analysis in order to modify the hybrid polymer composite to a better specimen. With that, thank you.